Welcome to Physics Trek. I'm Alan J, here with another work solution to help you improve your physics and to show you the best practice in answering questions. Here is just a reminder about all these questions we're doing on falling under gravity. They do assume that there is no air resistance. In other words, all the action takes place in a vacuum. So for objects falling down wells and being vertically projected from cliffs, you have to suspend belief for a while. Be patient. The full story of forces acting on bodies will eventually unfold, and then you can get to grips with understanding how the real world works. Well, at some level. You may understand how objects stop falling faster and reach a terminal velocity, but all this work assumes one other thing, that the acceleration due to gravity, g, is a constant, and it is more or less a constant for most human activities on or near the surface of the Earth. But when we get into celestial mechanics and start plotting courses to the planets, this is not the case. This is when things start to get a little tricky and of course really interesting. So do you see how easy these questions are? But first things first. At present you have to do your time in the sandpit. So getting back to the work in hand. Now this little question is in two parts and is fairly straightforward. It concerns an object being projected upwards and reaching a particular height, and all you are asked to find is the initial velocity and how long it took the object to reach the height. So let's get started. Here is our question. Question 3. A projectile is fired vertically upwards and reaches a height of 78.4 meters. Find 1. The velocity of projection, 2. The time it takes to reach its highest point. And first down the side, for quick reference, are two sets of equations for upward and downward movement. After carefully scrutinizing the question, we write out the information in symbol form. So u, the initial velocity, we need to find. V, the final velocity, is 0 meters per second. S, the distance, the height it goes, is 78.4 meters. And t, the time to reach that height, we need to calculate. And now to the diagram. Okay, the object is projected in the air. We don't know the initial velocity. Its final velocity is 0 meters per second. The height reached is 78.4 meters. We have to find the time to reach that height. And of course g is 9.8 meters per second. That acts in the opposite direction to the motion. It's a retardation. And now to the choice of equation. Remembering the initial velocity is up, motion's upward, positive is up. We don't have t, so we have to use this equation, u squared minus v squared equals 2gs. So let's just write that down. U squared minus v squared equals 2gs. Now we need to make u the subject of the equation. So we'll have u on the left and everything else on the right. We need to find u on its own, so we take the square root of everything on the right. So u is equal to 2 times 9.8 times 7.4 plus 0 squared, and the whole lot the square root of to the power of a half, which comes to 1536.64 plus 0 square root of, which equals 39.20 meters per second. And now to the second part of the question. Here we need to find the time it takes to reach maximum height. We use the second set of equations, and we use v is equal to u minus gt. So making t the subject, we take the minus gt to the other side, change the sign, take the v to the other side, make it minus v. So we end up with t is equal to u minus v divided by g. Putting the numbers in, t is equal to 39.20 minus 0 divided by 9.8, which gives us 4 seconds. And now the summary of our answers. For the first part of the question, the velocity of projection is 39.20 meters per second. And the second part, which we've just done, the time to maximum height is 4.00 seconds. 2 decimal places. And that's it. I hope this offering has been of help to you in some small way, and if you enjoyed the video, I'd really appreciate you giving the channel a like, a favourite or a subscribe. A little praise to do better goes a long way. Did you know that most of the unanswered intermediate mechanics questions are on the Physics Trek website now, so please feel free to have a go at any of them and stay ahead of the game. Anyway, do look out for the next work solution on the topic accelerated motion under gravity, number 4, coming very soon. And if you want to recap on the previous video, just click the link. Remember, any comments on the show, suggestions to make it better, or ideas for new videos are always welcome. Thank you all for watching.